So, welcome to the Webasto Arduino Shower project. This may be the first video in a series of videos of getting this to work. So down here, amongst this jumble and mess of wires, we have the Arduino, a breadboard, some MOSFETs and other resistors and components, patch wires, a spaghetti junction of wires going out to various relays and other things, of which I will explain all in good time. First of all, I thought I would just fire up and let you see it actually do its thing. Hopefully do its thing. So here is the said switch. I will talk you through what it's doing as it's doing it. So I'm going to push the switch. Ah, wait. It does help if you plug the power supply in. Okay, back at it. This time with the power supply plugged in. I press the switch. Press the switch. It pumps in a little bit of fuel to do start and turns the fan on. It then turns the glow plug on, keeping the fan on to get the fuel that is put in, hopefully to light. Hopefully. And it turns the fan on more while pumping fuel in. I don't think it's lit this time, but that's okay, because it has a few more I'll have another go at it if it doesn't light the first time. So it's detected that it hasn't lit this time. So I'll try again. Glow plug back on. Hopefully now we'll see some, there we go, bit of smoke. Don't know if you can see that on the camera, there's smoke. It's now lit. Okay, it's now lit. So it's now adding more fuel, glow plug's gone off, fan's on. As you can see, it's now smoking. Can you see it smoking? I don't know, does it show in the camera? This is where it proves me wrong this time and runs away quite happily. So it's now running, and the, what do you call it? The 10K thermistor that's stuck to the exhaust at the moment is reading the temperature, and when the temperature, I have to go through the code, but I can't remember how many it raises by, and it detects it has lit and it goes into full burn. It's not in full burn just yet. I don't think. I'll be honest, I can't remember what I set the settings to now, looking at them on screen, but it is running. Man! And it's nowhere near as smoky as it was last night. I did adjusted some of the code, well, off screen, and played with it. Some of your suggestions were to tweak the pump hertz and the fan speed. I have tweaked them. And it's running a lot better today. Oh, that's annoying. I was hoping to show you billowing plumes of smoke, but it's not. It's burning away quite happily. I'd also like to mention the water temperature is increasing slowly. So this video, I just wanted to show it actually burning, and then we'll try and build a proper shower, not a proper shower, but a better setup for the shower head and the water pump to run. Because at the moment, the heater's higher than the water, so every time we turn the pump off, all the water drains back out of here, so it can't measure an accurate temperature on the water, so the pump doesn't know when to come on or off. But at the moment there is hot water coming out of the... Not hot, it's not hot water, but it's hot enough. Wow. It's totally doing it. That's annoying. I was hoping she was billowing plumes of smoke and having to adjust everything, but so far so good. Okay, so what I'll do now is, well, turn it off, and then I'll go through all of these components and why I'm doing what I'm doing, and some of the code on the laptop. We'll have a look at that as well. Right, this should just be a push to turn off, I think. I have pushed it. I'm not sure what its timeout is. I'm hoping it just have to push it once to get it turn off. I'm looking at the code and it hasn't changed. Do I have to push and hold to get it to turn off? Yes, it would appear I have to push and hold to get it to turn off. So now, stop pumping fuel, thunders air through the burn chamber to get the last of it to burn out. And it just does that until it knows the exhaust's cooled down enough, and then it turns off, much like the original ECU does. So there you go, it's gone out. It's now just the inlet fan, the combustion fan, and that's it, it's off. Okay, it's stopped. Let's turn everything off. Except the water pump, we'll leave it running just to make sure that's pretty much stone cold anyway. We'll just let it run. You can see the smoke coming back out of the intake, which means there's still diesel in there, which means we should probably adjust the code so that it runs for a fair bit longer, I think, to actually flush out the last of the diesel. That might be a thing. Or how about perhaps even do what the Chinese dealer does and put the glow plug on for the last little bit, I don't know, 10 seconds or something, while it blows out the last of the... That might be an idea. But we can discuss all of that in the comments. We can chat. Stage one, I suppose, would be the hardware. So there is the Arduino itself, this blue thing over here with the big black chip in the middle. That's just the USB to serial programming cable. 4 MOSFETs, one for fuel pump, water pump, burner fan, glow plug. God, I couldn't even remember what it's fucking called there. And then pull-down resistors on each of the activation inputs for all of them. And then it's just all fed in from the common on the rightmost pin, and the middle pin is the actual output to other things. Mine currently output to relays. I know these MOSFETs should be able to switch and handle the load, but the breadboard and these thin-ass wires will not take the 10 amps of the glow plug, and they were doing a weird thing with the fuel pump, but I'll come back to that in a minute. Up there is... up here? Oh, where's my finger? These are the thermistor inputs and the resistors for them. There's one thermistor that goes onto the exhaust. It's currently just attached with Captain tape. Now the other one is on the water output, and this, well, essentially you should have this come out to a copper pipe and then have your thermistor bonded onto the copper pipe so it's got an accurate readout of the water output temperature. But mine is just currently jammed in there so I can get a rough reading. And back to this. That one is the input switch. It's just a momentary on-off, depending on what you press it. Like if you do a short press, it'll do one thing. If you do a long press, it'll do different things. Right, that's all of them. That is the glow plug relay, because as I said, the breadboard wouldn't take 10 amps. Down this mess of wires here is another relay I'm using for the fuel pump, because what the code would do is it would run in prime okay, it would click, 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 click and give nice big clicks for prime, but then when it came to run, it wouldn't do anything. Like I could see the voltage going up and down on the meter, but the actual pump itself wasn't doing anything. I don't understand. I honestly do not understand this, but if I take the same pulse out to a relay, it makes the relay clack away happily, and that just runs the pump. So the pump thunders away quite happily, clack, 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 and well, as you saw, it ran and did the thing. And what else is in this mess? I think that's about it for the mess of wiring. Everything up there is just plugs into that's the glow plug. That's the fan motor. There's a diode badly attached there, but it is attached nonetheless. Even though someone else said that these MOSFETs most likely will have an internal diode to protect them anyway. But hey, every little helps in not breaking things. The power supply over there is just running the pump constantly, because as I said before, the heater's higher than the water, so every time you turn it off, the water just drains back to the lowest point, which is the pump. So I think that just about covers it for hardware. So now that we know that it works, the next stage is to build an actual board, an actual proper circuit board that would have an Arduino at one end and your outputs at the other end, and all the components soldered on it. So all you have to do is attach your wires for fuel pump, water pump, glow plug, and what did I say there? And the burner fan motor. And you would just wire it in and put your thermistors into place, onto exhaust, onto the hot water output, and you're pretty much ready to shower. Smashing. And now what we'll do is go inside and look at this on a real computer and not have to worry about me trying to film the screen, because that's a terrible way of doing it. So yeah, it runs. There's not as much smoke as there was last night, which is really quite impressive. I need a bigger water vessel that feeds from the bottom. I don't know what to get. What does anyone suggest? What size or what kind of? Don't say an IBC. I'm not putting an IBC in here just to run this heater for a few goes. And also, I'm going to need you guys' help for either designing. I don't mind paying to have a board made up, or at least, you know, a blank board I can solder all the bits onto made up, but I have absolutely zero idea on designing this or any of that kind of, you know, PCB creation. Never created a PCB in my life. So help with that would be much appreciated. And then we'll get a board made up, and then we'll get all this tidied up and made into a smaller actual working shower, and we can run it and see it working as a shower, hopefully in the next video. Right, this is the website of the nice man here. He is the original designer and writer of the code. So this is his website. And basically, this is what we did. We got, well, we didn't get all these bits. We had, you know, the heater, not an Evo certainly, just a normal old, slightly older model Webasto. A dosing pump. We don't have an original Webasto dosing pump, but we do have the one that is the right size. We have a water pump, which I'll need to come back and talk to that once we get to the code. Basically, all of those things, the Arduino itself, resistors, thermistors, a switch, etc, etc. So we've got all that. And, well, we haven't done this bit yet. We've kind of just made a bastardized version of this, but it does the job it needs to do at the moment. And this is pretty much exactly what I made. This, give or take, is exactly how it should look. So that, basically, there's the Arduino and the MOSFETs and the resistors, the wires, thermistors, 5-volt power supply to power the top side, and down here would be your 12-volt, well, rail. You don't need two rails, you just need the one rail. And his board's a lot nicer and tidier looking than mine was, but hey. It is what it is. So moving on to then the code. He goes on and describes the bits of code, but his code didn't actually work. So there's his original code all there. You will either go on his website, I'll leave a link to his website, and I'll also leave a link to the code myself and Andrew knows who Andrew is. He has, well, he debugged it so we could actually get the thing to turn on and work. Which is slightly... What is a shame is, see that first board that I built? It did exactly the same as the second board, which means the first board was actually alright, and it was just the code that was wrong. Well, bad. Not bad. It's not bad code, it's just wrong for either what we were... But I mean, I copied exactly what he had built. The code should have worked, but it didn't. So let us go through it here as best I can. Basically, here is your ins and outs of where the, you know, the pumps and the fans and the temperature inputs, etc. And lots of other code and things. Well, there's the bit where that's the shower temperature that you want to get. 39 degrees? 39 degrees, is that good for a shower? I don't know. Anyway, so that's what it's trying to get. It's trying to get the shower temperature up to 39 degrees and stay at 39 degrees. That is its task. And in here, in amongst all these things, is it doing its best to do it. Right, let's go down a bit. So here's where we're getting the, you know, pressing the button, getting what the button does. And this one, is it this one? For the pump flow, that's the first part of the code, but I'll need to circulate. No. What I want to say is, the pump that I've got, it won't go slowly. Well, it will. It will, but it needs to start high. Like, it needs at least 10 or 12 volts to start spinning, and then you can bring it down to like 7 volts and keep it going. So what I need somewhere in here is the code that it would always start fast and then slow down. If that's a possible thing that somebody could write, that no matter what it's going to do, it always starts fast and then goes slow down. Because I think the pump, I'm not sure if the pump turns itself on and off while it's running, because we've not built the actual shower unit yet, but it says it like 95% because that's the voltage it needs to get the pump to go. But I need, like I said, I need it to start fast and then it can slow down, if this is a possible thing. Right, okay, this is our Andrew's written debugging thing, so we could actually work out what was doing what. This is the bit that talks about the states of, on, off, turning off, all those things. Now, this is what I've been dicking about with in the workshop, is the starting and stopping, not starting, but getting it to start and get it to run. So, firing sequence, putting in a little bit of fuel and turning the fan on. Now, if we look at the original code for this, on line 300, it's the same line, right? He adds like 60 fan speed, 90 fuel. It was too much. It was thundering fuel in there. It was like a smoke machine's going. So I've taken that down to 10 and 30. What did he have? He had 60 for the fan speed, or he might not have. I might have already changed that one. Don't quote me on that. That's right, 300. Yes, okay, sorry. He had a fan speed of 10. Now I found out my fan doesn't spin at 10. It will not spin at all. It does nothing. I think it doesn't actually do anything till like 20 or 30. So that had to get tweaked up so it would actually spin a lot less fuel. Get over there. Right, so we've got that does that, and then the glow plug comes on at this bit, which is fine. Clicks the glow plug on, the fan's still running. Oh well, every time I've run it so far, it is lit, and then once it's lit, the glow plug goes off, fan speed speeds up a bit, and starts adding fuel. And that's fine, and it will do that, and it ticks away until this temperature bit here. So the temperature increase of 1 degree. It was at half a degree. I tried 5 was too high because it would take too long to get there to detect it, but 1 is okay. If it sees a 1 degree raise in temperature on the exhaust, it knows that it's lit, and it'll go into the next stage, which is full power. Well, we'll call it full power. It's nearly full power. Fan speed at 60, fuel speed at 0.1. I'm not sure 0.1 actually works. I think it might just still be running at 1 because there's more code in here, and I don't think it understands a 0.1, if that makes sense. And then everything else is safety and turning off. Like I said, if overheating, turn the fuel off, keep the fan going. What else have we got? And then the last bit is snuffing the fire out. Now I've tweaked this to take the fuel off and run the fan hard, because what I wanted to do is blow as much cool air through the burn chamber as possible and get the burn chamber to cool down. So I need this to actually run longer, whichever part of the code in all these codey bits will keep the end phase going longer. Like it could probably do with run for a minute, because I think it checks to see if the exhaust temperature is stabilized and not keeps going up, but I want it to run longer than that still and make sure that it's actually cooling the chamber down with cold outside air. And after that, there's a bit about, this is for pulsing the fuel pump. Now the original code had a pulse of 11, and as I was saying before in the video, 11 it would prime the pump okay, but when it came to running it, then the pump didn't do anything. And if I turn it up, it works better, but it still gets to its running stage and doesn't keep running, which is weird. Hence we move to the relay, and it'll quite happily pulse the relay, and the relay will pulse the pump at a full 12 volts. Now there's a bit here about the Webasto fan running at 10 volts, and the code here assumes that we're inputting a 14 volt supply. I don't know why, because the only time you get 14 volts from a car or van is when the alternator is actually charging batteries, because 14 volts is not a, because well, I think what is the float voltage of your battery is actually like 13.8, but it doesn't stay there very long. As you know, things get turned on, it drops. But this doesn't seem to be bothering any of it too much. But it might be the reason that I need a higher value to make the fan run. Like it doesn't run at 10, because obviously it thinks it's trying to get 14 volts, which it's only getting 12, and it's less. So yeah. Anyway, that's not that bad. And then the glow plug one just basically turns the glow plug on or off. What's this? This is just about more safety features. You know, if exhaust temperature greater than 80 and water temperature greater than, turn everything off and stop being a heater, please. And there's just some more maths in here for coding. So that is all of the code that goes along with the heater and the diagram. So yeah, as I was saying in the video, what we need to do now is turn all of this into one nice circuit board that you can put an Arduino on, and at the bottom end have the outputs for all these things, so we can just wire them straight on, so it's nice and tidy, and we can actually set up a shower, and I'll put the proper thermistors onto the proper pipes so it can read properly, and we'll try and see if we can get it to be a shower, assuming of course that anyone happens to provide code that would let me run the water pump properly, so it can start fast and then slow down to a usable speed. But that's the stage one. Stage one was getting the thing to light and run, and it does. It currently lights and runs, which is great. I am so happy that we have managed as a collective to get all of this going, which is great. I'm really impressed. So thank you all. Thank you to everyone who contributed. Thank you to who told me about this, and then who told me. And then Andrew, of course, for fixing all of the code and actually getting this to run, as it didn't take too much dicking about in the workshop to dial in the numbers. They could probably still be tweaked to be better, but hey, we've got it going at the moment, so we're going with that. So, thanks for watching, guys.